So let's talk a little bit about how rolling without slipping connects to conservation of mechanical energy. When you see a problem, it says like the hoop rolls down a ramp without slipping. That's an important piece of information that tells you that there is friction present. Because if there was no friction, the hoop would slide down the ramp. It would not be able to roll. But the thing about friction and rolling without slipping is that the friction force does not do work in this case. And that's where people can get really tripped up. So if you have a block that slides down a ramp, that's like a rough surface, and then you also have a hoop that rolls down the same ramp without slipping, when they get to the bottom, what is the comparison of their mechanical energies like? So if we look at the block sliding down the ramp with friction, that friction force will do negative work on the system. So the initial potential energy that you start with will be greater than the kinetic energy that you end with. That's for the block. But if you have a hoop that rolls down a ramp without slipping, the friction force does not do work, and the initial potential energy that you start with, all of that will be converted into kinetic energy at the bottom. It's just a combination of translational and rotational kinetic energy, but your mechanical energy is conserved. So don't forget, if you have something that's described as rolling without slipping, that means that there is friction present, but it does not do work. So if that's your only external force, your total mechanical energy will stay constant and be conserved.